The excerpt outlines several critical conditions that must be met when considering the integration of a photovoltaic system with a subpanel. The excerpt doesn't explicitly grant blanket permission for connection to absolutely any subpanel, rather it stipulates requirements that the subpanel and the overall installation must satisfy. Firstly, the subpanel itself must be listed and specifically marked as being suitable for backfeed operation. This is a critical safety consideration. Not all subpanels are designed to handle power flowing into them from a source other than the main service. Backfeeding can create hazardous conditions if the subpanel is not appropriately rated and constructed to handle the reverse power flow. The listing and marking are confirmations from a qualified testing laboratory that the subpanel has been evaluated and found to be compliant with relevant safety standards for backfeed applications. Secondly, the subpanel needs to be field marked to clearly indicate the presence of all power sources. This marking serves as a vital warning to anyone working on the electrical system. It alerts them that power may be present from multiple sources, not just the main utility feed. This is particularly important during maintenance or troubleshooting, as it prevents accidental contact with live conductors that might not be de-energized by simply turning off the main breaker. Thirdly, the photovoltaic system must be installed strictly in accordance with all applicable codes and standards. This is a broad requirement that encompasses numerous aspects of the installation, including wiring methods, overcurrent protection, grounding, and disconnection means. Compliance with codes and standards ensures that the photovoltaic system is installed safely and reliably and that it meets the minimum requirements for performance and safety. Fourthly, the photovoltaic system must be equipped with a readily accessible means of disconnecting it from all power sources. This disconnection means allows for the complete isolation of the photovoltaic system from the electrical system, which is essential for maintenance, repairs, and emergency situations. The disconnection means should be clearly labeled and easily accessible to qualified personnel. Fifthly, the photovoltaic system must include a means of grounding the system. Proper grounding is crucial for safety. It provides a low impedance path for fault currents to flow back to the source, which helps to quickly trip over current protection devices and clear faults. Grounding also helps to minimize the risk of electric shock by limiting the voltage potential between conductive surfaces and ground. Furthermore, the excerpt emphasizes that any circuit breaker positioned between the main service and the subpanel must be distinctly marked as being suitable for backfeeding and must also clearly indicate the presence of all power sources. This marking serves to alert electricians and other qualified personnel to the potential for reverse power flow through these breakers. Standard circuit breakers are designed to protect against overcurrents flowing in one direction from the source to the load. When power is backed through a breaker, it can potentially compromise its ability to function correctly and in some cases could lead to damage or failure. Therefore, breakers used in backfeed applications must be specifically listed and labeled for that purpose. It's crucial to understand that the excerpt doesn't offer a definitive answer regarding connecting to any subpanel without further consideration. It's imperative to consult with a qualified and licensed electrician who can thoroughly evaluate the specific installation, taking into account local codes, the specific equipment being used, and the overall electrical system configuration. This professional assessment is critical to ensuring a safe and compliant installation. To elaborate on the conditions mentioned, firstly, the listing and marking of the subpanel as suitable for backfeed is not just a label, it signifies that the subpanel's components, including the busbars, insulators, and enclosure, have been designed and tested to withstand the stresses associated with reverse power flow. Standard subpanels may not have adequate insulation or busbar capacity to handle backfeed currents, which can lead to overheating and potential fire hazards. The listing typically involves rigorous testing by a nationally recognized testing laboratory such as Underwriters Laboratories or Intertek to verify compliance with relevant safety standards. Secondly, the field marking requirement for indicating the presence of all sources serves as a constant reminder to anyone working on the electrical system. The marking should be permanent and clearly visible, typically located near the subpanel's main breaker or on the subpanel enclosure itself. The marking should explicitly state that the subpanel is fed from multiple sources, including the main service and the photovoltaic system. This information is crucial for preventing accidental energization of circuits and ensuring the safety of personnel. Thirdly, adherence to applicable codes and standards is paramount for safe and reliable photovoltaic system installation. These codes and standards, such as the National Electrical Code, provide detailed requirements for all aspects of the installation, including wiring methods, overcurrent protection, grounding, and disconnection means. Compliance with these requirements ensures that the photovoltaic system is installed in a manner that minimizes the risk of electrical hazards and maximizes its performance and longevity. Fourthly, the requirement for a readily accessible means of disconnecting the photovoltaic system from all sources is a critical safety feature. This disconnection means allows for the complete isolation of the photovoltaic system from the electrical system, which is essential for maintenance, repairs, and emergency situations. The disconnection means should be located in a readily accessible location, such as near the subpanel or the photovoltaic converter, and should be clearly labeled to indicate its function. Fifthly, proper grounding is essential for safety and fault current protection. The grounding system provides a low impedance path for fault currents to flow back to the source, which helps to quickly trip over current protection devices and clear faults. Grounding also helps to minimize the risk of electric shock by limiting the voltage potential between conductive surfaces and ground. The grounding system should be installed in accordance with the National Electrical Code requirements and should be regularly inspected to ensure its integrity. The markings on the circuit breakers between the main service and the subpanel are also very important. The circuit breaker must be rated for backfeed. The markings on the breaker should show that the breaker can handle backfeed. These markings must be visible. The NEC, or National Electrical Code, provides very specific guidelines regarding photovoltaic system installations. Article 690 covers solar photovoltaic (PV) systems. The NEC provides guidance and requirements for safe and effective PV installations. Here are some key areas covered by the NEC related to PV systems. Firstly, there are general requirements. Secondly, there are circuit requirements. Thirdly, there are wiring methods. Fourthly, there is disconnection. Fifthly, there is grounding. And sixthly, there is overcurrent protection. General requirements cover the scope, definitions, and general requirements for PV systems. This includes proper labeling and marking of components and systems. Circuit requirements address the sizing and configuration of PV source circuits, PV output circuits, and inverter output circuits. It covers voltage limitations, ampacity calculations, and conductor sizing. Wiring methods specify the types of wiring allowed, proper installation techniques, and protection methods for PV system wiring, both inside and outside buildings. Disconnection requirements detail the number, location, and type of disconnect switches needed to isolate the PV system for maintenance or emergency situations. Grounding requirements cover equipment grounding, system grounding, and methods to ensure safety by providing a low impedance path for fault currents. Overcurrent protection addresses the need for fuses and circuit breakers to protect conductors and equipment from overloads and short circuits. Proper sizing and placement are critical. The NEC also includes specific requirements for a rapid shutdown, which is a safety feature to quickly de-energize PV system conductors in emergency situations. This is important for first responders. The requirements for rapid shutdown are in NEC section 690.12. Qualified personnel are required for the installation and maintenance of PV systems. Training and certification programs ensure installers have the knowledge and skills to work safely. Local jurisdictions have the authority to adopt and enforce the NEC. Compliance with local codes is essential for a legal and safe PV installation. The specific edition of the NEC adopted by the local jurisdiction must be adhered to. Regular inspections are vital to ensure ongoing compliance with safety standards. NEC tables such as 310.15b16 are used for conductor ampacity. These tables provide ampacity ratings for various conductor types and sizes based on insulation temperature rating and ambient temperature conditions. Proper conductor sizing ensures the safe operation of the PV system and prevents overheating. The NEC also provides requirements for labeling. Proper labeling of PV system components is crucial for safety. Labels should clearly identify components, voltage levels, operating currents, and disconnect locations. This information is essential for maintenance and emergency response. The NEC is regularly updated to reflect advancements in technology and to address new safety concerns. Staying informed about the latest edition and any amendments is important for installers and inspectors. The NEC provides detailed requirements for grounding PV systems. Grounding ensures that the system is properly connected to earth, providing a low impedance path for fault currents. This helps to protect against electric shock and equipment damage. The NEC outlines specific methods for grounding PV arrays, equipment, and conductors. These methods include using grounding electrodes, grounding conductors, and bonding techniques. The size and type of grounding conductors must comply with NEC tables and requirements. Proper grounding is essential for the safe operation of PV systems. The NEC provides requirements for overcurrent protection in PV systems. Overcurrent protection devices such as fuses and circuit breakers are used to protect conductors and equipment from overloads and short circuits. The size and type of overcurrent protection devices must comply with NEC tables and requirements. Overcurrent protection is essential for preventing fires and other hazards caused by excessive current flow. The NEC covers the interconnection of PV systems with the utility grid. Interconnection standards ensure that the PV system operates safely and does not interfere with the grid. Interconnection agreements with the utility company are typically required. These agreements outline the technical and safety requirements for grid interconnection. The NEC addresses the integration of energy storage systems with PV systems. Energy storage systems, such as batteries, can store excess energy generated by the PV system for later use. The NEC provides requirements for the installation and operation of energy storage systems, including battery sizing, overcurrent protection, and disconnection means. Proper integration of energy storage systems can enhance the reliability and efficiency of PV systems. The NEC includes specific requirements for PV systems installed on buildings. These requirements address issues such as roof load, fire resistance, and access for firefighters. The NEC also provides guidelines for the placement of PV arrays on roofs to minimize shading and maximize energy production. Compliance with these requirements ensures the safety and longevity of building integrated PV systems. The NEC provides requirements for PV systems in various locations. These requirements address specific environmental conditions such as high winds, heavy snow, and corrosive atmospheres. The NEC also provides guidelines for the installation of PV systems in hazardous locations such as areas with flammable gases or vapors. Proper design and installation are essential for ensuring the safe and reliable operation of PV systems in diverse environments. The NEC is a comprehensive document that provides detailed requirements for the safe and effective installation of PV systems. Consulting the NEC and working with qualified professionals is essential for ensuring a compliant and reliable PV system installation. Furthermore, regular inspections and maintenance are crucial for maintaining the safety and performance of PV systems over their lifespan. A qualified electrician should inspect the system. These inspections should include visual inspections, electrical testing, and performance monitoring. Any issues identified during inspections should be promptly addressed to prevent potential problems. Regular maintenance tasks, such as cleaning the PV array and checking connections, can help to optimize system performance and extend its lifespan. Maintenance should be performed by qualified personnel in accordance with the manufacturer's recommendations. Proper maintenance is essential for ensuring the long-term reliability and safety of PV systems. The NEC emphasizes the importance of proper labeling and documentation for PV systems. Labels should clearly identify system components, voltage levels, operating currents, and disconnect locations. Documentation should include system diagrams, equipment specifications, and maintenance records. This information is essential for maintenance, troubleshooting, and emergency response. The NEC also requires that PV system owners receive training on the operation and maintenance of their systems. This training should cover topics such as system monitoring, troubleshooting, and safety procedures. Proper labeling and documentation are essential for ensuring the safe and efficient operation of PV systems. The NEC provides detailed requirements for conductor sizing in PV systems. Proper conductor sizing is essential for preventing overheating and voltage drop. The NEC provides tables and formulas for calculating the minimum allowable conductor size based on the expected current flow and the conductor's insulation temperature rating. Factors such as ambient temperature, conduit fill, and voltage drop must be considered when sizing conductors. Using appropriately sized conductors ensures the safe and reliable operation of PV systems. The NEC provides requirements for overcurrent protection of PV systems. Overcurrent protection devices, such as fuses and circuit breakers, are used to protect conductors and equipment from overloads and short circuits. The NEC specifies the type, size, and location of overcurrent protection devices. Overcurrent protection is essential for preventing fires and other hazards caused by excessive current flow. The NEC also addresses the coordination of overcurrent protection devices to ensure that faults are cleared quickly and safely. Proper overcurrent protection is essential for the safe operation of PV systems. The NEC provides requirements for disconnecting means in PV systems. Disconnecting means are used to isolate the PV system from the electrical grid for maintenance, repairs, or emergency situations. The NEC specifies the type, location, and accessibility of disconnecting means. Disconnecting means must be clearly labeled and readily accessible to qualified personnel. Proper disconnecting means are essential for ensuring the safety of workers and preventing accidental energization of circuits. The NEC provides requirements for grounding PV systems. Grounding ensures that the system is properly connected to earth, providing a low impedance path for fault currents. This helps to protect against electric shock and equipment damage. The NEC outlines specific methods for grounding PV arrays, equipment, and conductors. These methods include using grounding electrodes, grounding conductors, and bonding techniques. The size and type of grounding conductors must comply with NEC tables and requirements. Proper grounding is essential for the safe operation of PV systems. The NEC addresses the issue of arc fault circuit interrupters in PV systems. Arc fault circuit interrupters, or SIs, are devices that detect and interrupt electrical arcs, which can cause fires. The NEC requires the use of SIs in certain PV system applications, such as PV systems installed in dwelling units. SIs provide an additional layer of protection against electrical fires. The NEC provides guidance on the proper installation and testing of SIs. The NEC provides requirements for surge protection in PV systems. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other transient events. The NEC requires the use of SPD in certain PV system applications, particularly in areas with high lighting activity. SPD diverts surge currents away from sensitive equipment, preventing damage. The NEC provides guidance on the proper selection, installation, and grounding of SPD. Effective surge protection is essential for ensuring the reliability and longevity of PV systems. The NEC provides specific requirements for PV rapid shutdown systems. PV rapid shutdown systems are designed to quickly de-energize PV system conductors in emergency situations such as fires. The NEC specifies the requirements for rapid shutdown systems, including the location of the rapid shutdown switch, the voltage levels that must be achieved during shutdown, and the labeling requirements. Rapid shutdown systems enhance the safety of first responders and other personnel working on or near PV systems. The NEC is a comprehensive document that provides detailed requirements for the safe and effective installation of PV systems. Staying informed about the latest edition of the NEC and consulting with qualified professionals is essential for ensuring a compliant and reliable PV system installation. The electrician must be a qualified electrician that has been vetted and knows what they are doing. Proper analysis of the system and equipment is very important for the safety and reliability of the PV system.